this video, we're going to be talking about negative exponents, fractions with negative exponents, and so on. So let's start with negative exponents. Basically, negative exponents have nothing to do with the sign of the base. A negative exponent is simply a way of saying that you need to move whatever the base is and that exponent to the opposite position in a fraction. If it's in the numerator currently, you need to move it to the denominator and change the sign of the exponent or the power. So in this case, this negative just says, move the 7 squared down here, which we did. If the negative exponent happens to be in the denominator, it's the same idea. You say, take this 2 cubed and move it to the numerator because it's currently in the denominator, and then evaluate it. Now, if you have a negative number, don't get confused. It's okay. So if you have a negative number, just treat it as anything. It's saying this negative exponent is saying take the negative 2 to the 4th and put it in the denominator because it's currently in the numerator. And then you can evaluate it as normal. And this is the same as saying negative 2 times negative 2 times negative 2 times negative 2. There's 4 of them together, and that's why you get a positive answer. But look, if you just have the negative in front, remember this doesn't have anything to do, this negative is not part of the negative exponent. It's like saying negative 1 times 2 to the 4th. So this part is handled separately than the negative. So you go ahead and take your 2 to the 4th and put it in the bottom. You could have left the negative up here, that's fine. And the exponent changes sign, but you still have that negative 1 that you had before, and then your answer is included. All right. If the negative in front of the base is not in parentheses, like this one up here, it's not actually included in the exponent, so you don't have to worry about that part. For example, this negative 6 is included in the exponent. This negative says, move it to the numerator, please, the whole thing. So here you go. Negative times negative gives you a positive. Whereas if you had this, you're only raising the 3 to the negative 4. So you put the 3 to the 4th down here, get rid of the negative. Evaluate it, and the negative stays at the end of the answer. All right, so let's look at these. You try them first. Okay, so this negative is saying to put the 5 cubed in the denominator, and that would be your answer, because 5 times 5 times 5 is 125. This is saying put your negative 3 to the 4th power in the denominator because it's currently in the numerator. And so when you multiply negative 3 times negative 3, which is 9, times negative 3, which is negative 27, times negative 3, which is 84. I got to do the little calculation here. Okay, 81, sorry. Okay, so you get 1 over 81. All right. 8 to the negative 1, again, this negative is just saying put the 8 to the 1 power in the opposite place, and 8 to the 1 is the same as 8. Now this is the same as having negative 1 times 3 squared. This is actually negative 9. I think this was supposed to be a negative, but if you had that, you would have negative 1 over 3 squared, and this would be negative 1/9. So there's a difference between these two here. All right, let's look at the next part, fractions with negative exponents. All right, so what you're going to do is you're going to treat each part of the fraction separately. All right, then evaluate. So this 4 to the negative 3, remember the negative just says, hey, put this guy down here. And this 5 to the negative 2 says, hey, I'm in the denominator, move me up to the numerator, which is just the same as before. And then you evaluate each piece like you would before. X to the negative 5th says, hey, put this x to the 5th in the denominator. Y to the negative 1 says, put the y to the 1st power in the numerator because that's where it's not. And then evaluate. Remember, if you have an exponent of a fraction, each part of the fraction is subject to the same exponent or power. So 3 to the negative 2 and 4 to the negative 2 are both basically what's happening here. You put the 3 squared down here and the 4 squared up there. They're changing places, and then you evaluate. All right, so try these. The answers are off here to the left, but we'll work them out just in case. So this is the same thing as saying 7 squared needs to be on the top, and 2 cubed needs to be on the bottom. This becomes 49 over 8. So this is the same thing as saying 4 to the negative 2 over 5 to the negative 2. So we switch places. And so we get 25 over 16. Luckily, that's the right answer. All right, now keep in mind this 1/7 has nothing to do with the negative part. The only thing you need to worry about is that the y squared needs to change position. The 7 doesn't have to do anything. It's not part of the negative exponent. And then in this last case, x to the first power is going to go on the bottom, and y to the 8th power is going to be in the numerator because it's changing places. All right, let's talk about how to simplify exponential expressions. Once again, you want to make sure that if they're being multiplied, you add the exponents. If they're being multiplied within the exponent, each part is subject to the exponent. And then you want to simplify each power. In the end, you can only have positive exponents in your final answer, okay? All right, so in this case, you have some x's and some y's. We already know that anything to the 0 power is 1. We know that you can take the numerator, subtract the denominator, and that's how many x's you'll have left. Since this happens to be a negative, we're going to move it right back down to the bottom, just like we did before. Here are some other examples of how to simplify exponential expressions. So take a look at them. Okay, let's try some on your own, and then we'll look at the answers. All right, in this case, since the bases are being multiplied, we're going to add the exponents. So we're going to get x to the negative 10th, and we know that that means, hey, put the x to the 10th power in the opposite spot on my fraction. So 75 divided by 5 is 15. X to the 3 minus 9 is x to the negative 6. We can't have negative exponents in our answer, so we'll put it in the denominator or where it's not. 50 divided by negative 25 is negative 2. Y to the 8 minus 14 is y to the negative 6. This negative 2 is not part of this exponent, so it just stays where it is, and the y to the 6 has to move. Each part of these is being raised to the power, so this means 6 squared, and then we're multiplying these two numbers to the 8th, x to the 11th, and y to the 0. Well, we know y to the 0 is just equal to 1. Anything times 1 is itself. So 6 squared is 36. We have 8 minus 11, so that's negative 3. And then the 1 stays where it is, and then now we have to move the x cubed to keep a positive exponent in our answer. Each of these are raised to the same power. So 8 times negative 5 is negative 40. And 4 times negative 5 is negative 20. All right. We can do it this way. I'll show you another way too. But anyway, so negative 40 minus a negative 20 is the same thing as negative 40 plus 20. So we get negative 20 as our leftover. And so then it's 1 over x to the 20th. What we could have done as well is simplified what's in the parentheses first. 8 minus 4 is x to the 4th raised to the negative 5th power. That gives me x to the negative 20th, which is 1 over x to the 20th. So you could have done it either way. That's fine. Let's talk about scientific notation. Now, why do we use scientific notation? Basically, we're using scientific notation to express very, very, very large numbers or very, very, very small numbers, meaning numbers that are between 0 and 1. All right, they're always in the form of something, dot, possibly other digits, times 10 to the something, and n is the power. This number that's in front of the decimal place, can only be numbers 1, 2, 3, 4, 5, 6, 7, 8, or 9. They can't be 10, they can't be 0, and they can only be one digit. So it's only one digit. N, which is this exponent of the 10, is the number of spaces that you move your decimal, okay? This n is positive if the number is greater than 1, or as I like to say, if this value is what you would want to win in the lottery, it's a positive thing. However, n is going to be negative if the actual number, the value of the number that you're putting in scientific notation, is a fraction. If I won 10 cents in the lottery, it wouldn't be worth the drive to go pick up the 10 cents, okay? So that's a negative thing. So here's some examples. The universe is about 13, let's see, that's 1,000 billion years old, okay? And so here's the number expressed normally. We need to express it in scientific notation. Only this first digit, this number 1, gets to be in front of the decimal. All the other numbers that are not ending in zeros are going to just go after the decimal place. Now, since I moved the decimal that's originally here over, we'll find out how many spaces, but anyway, since I had to move it over this many spaces to go here, that's what's going to end up going in the exponent of the 10. So it's always going to be a number times 10 to the power of something. That's part of what scientific notation is. So here's where I moved my number. I started over here where the imaginary decimal was in the original number. I moved it 3 spaces, 3 more spaces, 3 more spaces, and then another space. So I ended up moving it 10 spaces. So I put my 10 here first. Then I go back and say, is this a positive number? Is this a big number? Or is this a small number? Since it's big, then my exponent is positive. And so that means that the Earth is about 1.375 times 10 to the 10th years old, which is weird looking, but it's a lot less cumbersome not having all those zeros that you have to put in. And by the way, this number and this number are the same value. They're just written in shorthand. Let's do a small number. Okay. So the length of the AIDS virus is about 0.00011 millimeters. Okay. We only get to use going from left to right. We pick our first number that's not 0. Here it is. Okay, so that's the digit that gets to be in front of the decimal. Anything after that gets to be after the decimal unless it's a bunch of zeros. Then we don't need those. All right, so now we're going to say, okay, we're going to keep the 1 and everything else goes after the decimal. So I know it's going to be in this format. So now I know where I want my decimal to be. My decimal is currently over here, so I'm going to end up having to move it. Now this first 0 is just to call attention to the decimal place. So we started with the decimal here. We had to move it this many places. 1, 2, 3, 4. Okay, so we had to move it this many spaces. So the 4 goes here. So we have 1.1 times 10 to the 4th. But then you decide, is this 4 going to be positive or negative based on the size of this number? This is a very, very small number. It's less than 1. So therefore, the exponent must be negative. So then you rewrite it as this way. All right, so try these. Okay, currently my decimal is here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to move it to here because my 7 gets to be in front of the decimal place. My 4 is afterwards because it's the only non-zero number. Times 10 to the power, and we decided we moved it 3, 6, 9 spaces. So we're going to keep this. Then we go back and say, is this a large number or is this a small number? It's clearly large, so we're going to keep the exponent as positive. All right, so we're going to keep this 3. This is the first number that we get to have, so we're going to say it's 3.017 in our final answer. So we're going to have to move the decimal 1, 2, 3, 4, 5, 6 places. So you go ahead and write it like this. Then you go back and look at the number and say, this is a really small number. It's definitely less than 1. So we're going to change our exponent to be negative. Similarly, here's where I want my decimal place because I only get 1 digit before the decimal. Now I need to find what my n is. So that means I'm going to have to move my decimal 1, 2, 3, 4, 5, 6, 7, 8 spaces. This is definitely a small number that's less than 1, so you keep the negative, and that's how you do it.